Hi everyone. Today we're going to be looking at table saw safety. We are working on a SawStop industrial cabinet saw. However, many of the rules that we're going to be talking about pertain to any type of table saw. However, there are some safety features that are specific to this saw. Um, Many of the setup things that we'll take a look at today, as well as just safety, will pertain to many, if not all, table saws out there. Okay, as always, please make sure you are following all of the safety rules that we've already discussed. Make sure you are abiding by your specific manufacturer's safety protocol for their piece of equipment. So, let's take a look at initial setup, how we use this saw, some safety, so on and so forth. First thing we're going to take a look at is power shutoff on this saw. We have a main power button here that we can flip down. We also have a complete disconnect on the side of the saw, which we are going to throw when we are actually in the throat of the saw or making adjustments on this tool. Okay. Right now we have this guard on the saw. I'm going to actually remove that guard, so I'm going to pull the throat plate by lifting up on this little lever and actually pulling directly towards me to remove the throat plate. This saw has a couple safety features built into it. We have these anti-kickback fingers, which I'm just going to lift and clip out of the way onto the guard. And we also have a riving knife, which is built into our guard. Okay, occasionally this guard will have to be removed when we're making thin cuts or cuts where the guard actually makes it more dangerous. In that case, the bare minimum that we will need to run on this saw is a riving knife. This riving knife can get dropped back in, the lever can get placed down, and the throat plate can go back in place. The function of the riving knife is as you go to cut the board and the board passes through the saw blade and the kerf opens up, the riving knife will actually keep the two pieces of wood separated. It will also prevent any internal stresses in the wood from actually closing that kerf onto the saw blade and creating friction. So the riving knife is very functional and does help us a lot. For this cut, because I am dealing with a board which is 6.5 inches in width, I am going to remove the riving knife and actually place the full guard back in place. Guard gets dropped in. Make sure your anti-kickback fingers are up. Gets clamped on the riving knife, and the throat plate can get slid back in place. Check when you're dealing with your throat plate that the throat plate is flat and level across the whole surface. Occasionally, sometimes these things can actually sit up a little bit. You know, it's exaggerated, but right now you can see them about an 1/8 inch up. Make sure this is actually flat and level. My kickback fingers can drop down, okay? And what the kickback fingers are doing is, as the board passes through and by the saw blade, the kickback fingers are actually grabbing that wood, okay, where I can't pull this board back anymore. So these fingers are actually helping. In the event of a kickback, they will actually grab that board and prevent it from coming at you. Okay, so they are very beneficial as well. I'm going to lock those out of the way and then drop them back down so they are active. This portion just protects or covers the actual saw blade itself. Although your hand should never be entering in that direct blade path, this will cover the saw blade to help prevent you from entering that, or at least showing you that your hand should not be entering into this zone. Okay, so now that my riving knife, kickback fingers, and throat plate are all set, I am going to turn my main disconnect back on the saw. I will wait to power up the saw, but the main disconnect is back on. When we look at the table saw, this blade that is currently in our table saw is a combination blade. So what that means is this blade is designed to both cross-cut and rip wood. All right, we're going to take a look at ripping wood first. Okay, and when we talk about ripping wood, what we're actually speaking about is when you look at the grain structure of this wood, when we are cutting with the grain, it is considered ripping. When we are cutting across the grain, it is considered cross-cutting. And I'll show you proper setup and procedures of how to cut with both ripping and cross-cutting. First, we'll take a look at ripping. So the first thing that I did to this board is you'll notice that this board is planed. Although it doesn't have to be, it is planed, smooth on both sides. You'll also notice that I have jointed one side of this board, okay? A jointed edge is critical so that your board remains flat and true on the fence when you were running on the fence. If you do not have a jointed edge, as this side is not jointed, you can see there are slight gaps between the board and the actual table, which could allow this board to move left and right and not give you a true straight cut, okay? So the jointed edge will be going against the fence during my cut, and it's critical to make sure that you actually have that jointed edge against the fence. Occasionally I'll see people who will joint one edge, and then what they will actually do is have that jointed edge out away from the fence, which is doing them no good. Okay? So we got to make sure that we're placing the jointed edge towards the fence. Now, when we look at the fence should be used for ripping only. When we go to cross-cutting, we will actually remove the fence, all right? And you'll see the miter gauge that I will actually use for my cross-cutting action, okay? So at any given time on the table saw, you should only be using one means of support. In this case, it is the fence. If I'm cross-cutting, I'll be using the miter gauge. All right. Now, with that said, this fence is adjustable, where we have up to 52 inches of travel that we can actually cut and rip with. So if you're dealing with large sheet stock like plywood or anything large of a big glue up, you can actually use a big distance for your ripping process. On any piece of equipment, I recommend that you do check the measurements on the fence. Okay, so to do that, what I would recommend is set this to, let's say, 10 inches on the fence, lock it, and then double check the measurement with your tape measure between the fence and the inside of the tooth of the actual blade, okay? What's critical is that you are measuring on this side of the blade. If you are on this side of the blade, you will actually be off by the thickness of this blade or the kerf of that blade, okay? So in my case, we're running an 1/8 inch blade. I'm going to make sure I'm measuring between this side of the saw blade as well as this side of the fence, okay? So I'm going to measure that and double check we do have 10 inches exactly, which means that our fence measurement system is accurate, okay? Occasionally, as these fences get beat up, people change out the thickness of the actual fence, which will throw your measurement off either 1/4 inch or even more drastically sometimes, okay? So double check that. At this point, what I'm going to do is set up the height of my saw blade. When you take a look at this saw blade itself, right now I'm sticking up very, very high. So when you take a look at how high this blade is, I'm going to drop this blade down until I am 1 tooth above my material. Now remember, as I am touching this saw blade, I am still powered off and I have a main disconnect off, okay? So this saw blade cannot come on, all right? So I'm 1 tooth above the material, which is a good height. Any higher than that is just excess blade height, which is what we do not need. So now we have my blade height set. Next thing is to actually set my fence where it needs to be. I've already double checked the fence. The fence has the correct measurements, all right? So now I'm gonna set up for my cut. In this case, I'm gonna make a 4-inch cut on this board, or a 4-inch rip, all right? So what I'll do is I will actually set my fence to 4 inches. I'm gonna double check once again. The old adage, measure twice, cut once. So we have 4 inches exactly, all right? Going to drop down my guard. Going to grab a push stick and place it within arm's reach, all right? And make sure that my jointed edge is going against the fence, all right? Now, when we talk about proper stance at the table saw, this is a critical piece, okay? Just as critical as danger zones, as we talked about being directly in front of the blade path. The danger zone is also where you are standing while operating this machine. In the event of a kickback, this saw is going to grab the wood and throw the wood directly back in this direction. So with that said, if a kickback were to occur and I am standing directly here forcing this board in, that board is going to come at a very, very fast velocity at you, strike you in the stomach, and take you down to the ground, which is going to hurt very, very bad. So when operating, you need to stand to the side of this blade path so that if a kickback occurs, it goes beyond you and through the back, okay? You do not want to be hit by a kickback. So I'm going to stand to the side. My hand position, what I like to do is have a pointer finger and a thumb. Your pointer finger gets pointed towards you, so it's away from the blade, it's towards you. Your thumb is on top, making this 90-degree L, okay? Pointer finger towards you, and it gets planted to the top of the table. Your pointer finger will not be moving. This left hand will not be moving, okay? Thumb is designed to hold the board down and flat. The pointer finger holds that board tight to the fence. So you're making this L, which is allowing this board to slide through your hands, okay? Holding it flat to the table and tight and flat to the fence. This board is functioning as a feather board, okay? Excuse me, your hand is functioning as a feather board in this particular case, okay? So, when I make this cut, what you will notice is I'm going to have my left hand planted, right hand is going to feed the board. I'm going to travel all the way to the point where I'm about 4 to 5 inches from the danger zone, which is entering directly in front of that blade. I will then keep my left hand planted firmly, grab my push stick with my right hand, push down and forward, making good contact with the board along the fence, and push this board all the way through as it exits the saw. My left hand is going to be planted here. The left hand is planted here so that you do not reach in for scrap, okay? Right hand pushes through all the way, left hand gets planted on this far left-hand corner of the table saw, okay? What you will also notice is, as I said, we are not reaching in for scrap. Many accidents and injuries occur due to people, after making their cut, reaching in for scrap, not thinking about that blade still spinning, and catching their finger, okay? So, I can now turn on my main power disconnect of my saw. We are actually getting ready to actively make a cut. Make sure the table saw is clear and free of debris, such as pencils, any other object. I'm going to throw the main paddle to turn this saw on, and watch my procedure as I work through this saw. Everything we just discussed will actually take place in very fluid action. Standing to the left, pointer finger, thumb, planted. I start feeding. Enter that 5-inch mark. I keep holding the board with my left hand. I do not let go of the board. Grab my push stick. Push stick pushes through. Left hand plants. I get this board all the way through. It exits the saw. Push stick gets put back. Saw gets turned off. Now, what's critical is you must wait for this saw to come to a complete stop. All right, on this saw, it has a blinking light signifying that the blade is still spinning. You can also listen for the blade. I also recommend after you think it's stopped, you can wait an additional 20 to 30 seconds to make sure it's completely stopped. At that point, you can lift the guard if you need to, remove your scrap wood, grab your cut piece. Another important note I want to make before we leave is beginners tend to watch the blade, okay? The blade is where you do not need to be watching. What you need to be watching is this fence area. You want to make sure that your jointed edge stays in contact with the fence area at all times. So when I'm cutting, I'm actually watching that jointed edge to make sure that as I feed this board, that jointed edge stays in contact, okay? What you do not want is that jointed edge to stray from the fence. So in other words, as I'm feeding, it starts to actually stray, which can really cause some issues, okay? So we're not watching the blade, and in our case, the blade guard and the blade is actually covered, okay? So we are watching the actual fence area and passing this board through, keeping that eye on the fence, all right? Now, we are going to set up for a cross cut. That was a rip, okay? So for a cross cut scenario, we are actually going to remove the fence completely, okay? And I'll explain why. We are going to grab a miter gauge. which is hanging on our saw. Okay, and it's called a miter gauge because you have this T-slot which slips into the T-slot of the saw, but you have these miter angles which you can adjust the different angle depending upon what degree you need to cut at. We're just going to be cutting at 0 or 90 degrees. Okay, so I'm going to place my miter slot in one of my T-slots here. Okay, and the reason we remove the fence is we do not want friction to occur. So friction can occur in between the blade and the fence when I go to make this cut. Okay, and what I mean by that is as I pass through this blade, this board can get caught in here and actually spin at a slight angle. As that board spins, it's going to catch the fence, catch the blade, and have no choice but to actually come flying back or get kicked back. Okay, so by removing the fence, we now give this board an opportunity to be free over here. It's not going to get caught or have friction against the fence. What is critical is that you either are using a fence or a miter gauge. You should never, ever, ever try to freehand a cut on a table saw. Okay? You need to have one of these two safety procedures in place. So, we are using the miter gauge in this case set at 0 degrees. Our blade height remains the same as we are still set up for the same thickness of material. Okay? In this case, I would have measured and marked where my cut needs to be. So here's 12. I'm going to place a nice V mark. And the mark is going to travel on, in this case, this is my 12. Here's my scrap. I'm going to keep my mark on this side of the tooth so that I'm getting a true 12 inches. I'm not a 1/4 inch or, excuse me, 1/8 inch too short. Okay? So when we go to operate this, once again, we're keeping our fingers completely out of the blade path, which is the direct line in front of the saw blade. Our guard can come down. I'm going to grip the board and the actual miter gauge like this. I'm going to grip this other side, and as I pass through, I'm just making sure that the boards actually get separated and stay separated. They don't come back together. Okay? So saw comes on. I travel through all the way. Saw comes off. You will notice I passed through the whole blade path. I did not try to bring the miter gauge back with the board in place. I actually brought it all the way through, separated my boards, and let them stop.